called the model as underfit. Model is not able to learn the pattern. Model is not able to learn the pattern. That means there's a high error. So you said, why are we using the errors? This is how we know. If there's a high error, then that means the data is underfit, right? High error of what? Of training data. There's a high error in the training data. That means the data which you have provided, it has errors. Similarly, you will get high errors in the testing part also. Why? Because in the linear relationship, or like in a supervised learning algorithm, we give X and Y both. So yes, there's a high error in the training data set, high error in the testing data set. That means the model is not able to learn the pattern. And to avoid this underfitting thing, what do? We add more data, right? Because the data is inadequate here, right? It is inadequate here. So this is how we talk about the underfit model. Now you have your normal model, which is like, you have this, you have data points around it, and this is like your normal linear regression model. Now there is another condition, right? And that condition is that data is too much. Lots of data points you have, like it is so many. Lot of data points it has. Everywhere, so much, everywhere. So what your machine learning algorithm does when it has lot of data, it tries to learn every other points. It tries to include all the points in it. So many data you have provided. It will always give you a squiggly graph. That means if we talk about giving more data, too much of the data, then it becomes the case of overfitting. It will try to pass through all the points and make the curve complex. Now, can you see how this curve is? See, this is a simple straight line we should get. Linear regression. And what is this? It is trying to accommodate every other data point. Here, what happens? Here, the training error is less. Why training error is less? Because we know that we have given lot of data, but testing error is high. Why testing? Because you have given so many data points. That's great. But when the machine tries to fit in the model, it is overfitting. It is not understanding and it is giving you some high errors. This kind of model is known as overfitting model. So what are we trying to achieve? The question that you asked, when you get high errors, that means there is either underfitting or overfitting in your models. The model is not able to understand. So the best way to go through it or to get the best model is we should always try to achieve an optimal model. What is an optimal model? Which should have a low error in the training, also low error in the testing. So now when you have to achieve this model, the optimal model which we are thinking of, this should be our model. It is also known as generalized linear model. So basically, our aim should be to get an optimal model or a generalized linear model where your error in the training and the testing data set should be low. And to make the overfit model to be the optimal model, we can use a technique which is known as regularization. So what is regularization? It is a method to address overfitting and improve the model performance. Why are we seeing the errors, the underfit and the overfit models? Because underfitting we can solve. The data is inadequate. We can keep on putting more data. So this is easy. You can give more training data sets. But if it overfits and still we need to improve the performance of the model, then we should go for the regularization.